Hi, you know what? Recently I realized that from time to time I see the need to use some sort of lens in my projects, but I just keep leaving it for later. Like for example in this video where I've been testing which artificial light source works best with solar cell. I still need to collimate the light with lens, but that's completely different technical challenge, so I leave it for a separate video. Besides, there is some magic in optics which I always wanted to explore, but never had proper lens, and ordering professional grade products just to play a little doesn't seem reasonable, especially that I don't have enough experience to even know exactly what I want. So I want to find out, is it possible to make lens at home, preferably not just spherical but of any shape I would design, and for sure I don't want to spend months building complex devices for this process. It's supposed to be reasonably simple rather than super precise. With project requirements defined this way, plexiglas, also known as acrylic glass, seems to be a perfect material as it's commonly used for low-cost optics, easily available in many shapes, and can be formed using a wide range of methods. There is just one tiny problem. I almost have no experience on shaping plastics otherwise than with 3D printer. So I need to experiment a little. If you're curious what can be done with plexi at home using simple methods, and if I will be able to produce anything that makes any sense, here is the video. I have this leftover piece of plexi standing in the corner of my workshop for a few years already. Should be good enough to get a clue on what am I dealing with. I will cut a few random pieces and just play a little. As mentioned already, there are few ways of forming plexiglass. It can be machined or cast using acrylic resin, but this time I'm particularly interested in thermoforming. One of the reasons is that recently I made precise automation for my hotplate. You can see it in this video on my channel if you're interested. So I want to give it a try, but there are more important factors. Two-component resins can't stand on the shelf for infinite amount of time, especially after being open. They need to be mixed in a precise ratio, which can be problematic when you need just a small quantity like I do, and they usually need around 24 hours to fully cure. With thermoforming, theoretically, I should be able to just take a piece of plastic I want, melt it, form it, and after a few minutes of cooling, I should have my part ready to use. Theoretically. Means there must be a catch. Okay, so let's test it. I just arrange my hot plate a little and heat it up. Don't know yet which temperature will be optimal, so I start with 150 centigrades, and after the temperature is stable, I can add my sample. It's definitely not flawless, but for the purpose of this test, it doesn't have to be. And almost immediately I can see something is going on. Don't know yet if it's good or not. After around 5 minutes and closer examination, I can clearly tell that it wasn't a good sign. Now my sample is filled with many small bubbles, which can be generally divided into two categories. Big ones that exist within the entire volume, and the fine ones that occurs only on the contact surface. That probably means they have two different origins, which I will have to deal with eventually, but never mind for now, let's just check how it will go with forming. Sample doesn't look too liquefied right now, so I will raise the temperature to 180. Nothing significant happens, so 210. Okay, something happened this time. Still doesn't look like a drop of water, but let's try to press it with something. Yeah, why not a spoon? Well, it is soft, but definitely not as soft as I would like it to be. Additionally, there is a great difference in viscosity between top and bottom of a sample. And well, no wonder, plastics are generally poor heat conductors, So if I had heat source below and free air above, it must have produced great temperature difference top to bottom. So for sure there is a lot to improve, but like for the first test, I'm pretty happy with the results. Sample is flat on the bottom, concave on top, just like it should be. Those concentric lines probably means that material was rather bending than flowing, but that's clearly because it was simply too cold. Something more interesting happened on the bottom. I always thought that professionally made plastic parts are able to reflect every tiniest detail of the form due to extremely high pressures used during injection process. But here I also have the exact image of every smallest scratch preserved on my piece of plexi. Means pressure has nothing to do here, because what kind of pressure I could have produced with a spoon? It's rather related to adhesion forces or something, but I don't know much about surface effects, so I won't speculate more. If you know why it happens, you can share it in a comment. Alright, so for the moment, my biggest concern are bubbles. Regarding those big ones, I have a good clue on what can be the reason. I have a 3D printer, so I heard a lot about the importance of keeping the filament dry. Most of plastics absorbs moisture from the air. Later on, as plastic is heated, it turns into a steam, and results are as you could see. Just a quick googling around, and I found this pretty comprehensive guide on injection molding of plexiglass specifically. As expected, PMMA is moisture sensitive. It's even explicitly stated that presence of water causes bubbles to appear within material. Fortunately, a remedy is pretty simple. 80 to 90 degrees, 3 hours or more. Considering how I've been storing my plexi, it will probably be the more option in my case, but we will see. If I already found such document, I will check melting temperature as well, and yeah, no worries, range is quite wide. 210 to 270. So let's try a quick drying. I don't want my plexi to be in direct contact with the surface of hot plate, so I use such spacers made of Teflon. Its melting point is above 300 degrees, so it should be okay. On top I put piece of aluminium plate and surround everything with this quickly made piece of thermal insulation. I just added washers below to make sure there will be some air circulation. Then I place thermocouple in the air this time, close it with another piece of insulation and heat it up to desired 90 degrees. Once that's done, I place my sample on the plate and leave it like this for a few hours. In the meantime, I printed this convex shape of ABS. Been using fast settings, so I had to smoothen it with acetone. Not the most precise method you can imagine, but I also don't expect spectacular results yet. Just want to check what will happen to ABS in contact with molten PMMA. Meanwhile, my sample spent about 3 hours drying. It's already late, so must be enough for now. I raise the temperature to 150 and compare the results with previous test. Nice, there is definitely a progress. Still can see some bubbles, but way less than previous time. After all, I was expecting that my plexi will need more than 3 hours of drying. Time to melt it. I will keep 210 degrees for a few minutes, and while waiting, I apply a thin layer of Vaseline to the shape, which I hope will not allow both materials to stick together. I think plexi is good already, so I can finally perform the test. And well, looks like Teflon spacers actually didn't make it. Whatever, let's just press the sample. I can feel it's pretty soft this time. Maybe placing thermocouple so high above the sample wasn't actually the best idea. If hot plate temperature was well above 300, then for sure it wasn't 210 on the sample level. Okay, but what about the sample? Good news are, Vaseline did the job. Parts didn't weld together. But unfortunately, here I can see a pattern that looks just like the infill of my shape. Yep, this one. Means the surface already started to collapse due to high temperature. But there is one more thing worth mention. This time those small bubbles appears only in the center of the sample. And I'm sure it's related to the fact that this time it bent a little upwards while heating up. I think those bubbles are simply caused by the air that got trapped between plate and plastic. So to prevent them, it should probably be enough to just avoid surface-to-surface contact during heat up. Nice, need to try it next time. Now as I know that my samples needs drying, I start the day with reassembling my improvised oven. This will be my spacer this time. It should prevent the heat from hot plate to propagate directly into samples plate, so I hope temperature around samples will be more uniform. Additionally, I bent part of samples plate to form a pocket for thermocouple, so that temperature reading would take place exactly on the samples level, not just somewhere in the chamber. Previous time I could not trust it, especially on higher temperatures. Drying is a long process, so I load more than one sample this time. I'm sure I will need a lot of them in near future. I also put even more samples into a jar with silica gel. Maybe it will help somehow with drying them later. Once that's done, I can finally play with some more interesting things. Some time ago, I accidentally discovered that 3D printed parts are strong enough to be dies for sheet metal forming of thin aluminium plates. Later on, I even seen videos with people using them to form steel plates, so I'm pretty confident that those can deal with my 0.7mm aluminium plate. Shape is spherical, so I think I don't need bottom die to be full. Such brim should be enough to make metal bend around the top die. Speaking of which, well, I never been printing in high resolution, so I still need to find proper settings for the prints to look good enough. For now, I need to help myself with acetone, but I will get there eventually. Now I just need to press it. I'm sure I don't need much force for that, so I try with just a carpentry clamp. Okay, I have enough force, but I definitely have problem to apply it perpendicular. I can see the tip is tilted. Well, okay, I'll try to press it a few more times. Time to check the results. Not so bad, it lies on the top die nicely, it's concave. I can see some imperfections, but die itself wasn't perfect and I had to press it several times, so I guess that can be easily improved later. I also could have polished it first, but let's just try it. This time samples spent around 4 hours drying. I'll put spare ones into silica gel and heat up one of them to 210. How does it look after a few minutes? Okay, I have forgotten to support it with something to avoid surface-to-surface contact in warming up phase, so once again I have those small bubbles, and 2 huge ones additionally. But at least there is further progress with big bubbles. Only few of them left, so looks that regarding drying, it's just a matter of time. Okay, let's press it. It feels quite hard, so probably I should use higher temperature next time. Yeah, looks it's solid already. So once again I can see those waves on the surface, but it's quite clear and convex, so for me it looks like a progress. Still the bottom surface looks bad, as aluminium plate wasn't polished, so let's try if I can polish it now. I just use ordinary metal polish compound and small piece of rag, and just a few moments later the surface looks like this. Still can see some small scratches, but considering that I spent only around 20 seconds polishing, I can honestly say that I'm quite impressed with the result. But for sure, it would have been better if I had my bed plate polished as well. Okay, let's try how it goes if bottom die is full. I will need it anyway if I like to try making a spheric lens eventually. I leave some space between dies to accommodate the plate, and for now I use rather small curvature, as I don't want to use too much filament until I figure out the proper settings for fine printing. Yeah, still didn't fight them. Surface looks awful. To make things more funny, I ran out of filament on last few layers, so the bottom die is also not fully printed. But whatever, I'll try to press it with drill press this time. At least it should be a bit more precise than carpentry clamp. Right, means I need to work on my dice a bit more. Okay, not perfect, but it's not yet time for perfection. Let's just see what will happen. Okay, this time's results are, let's say, acceptable, at least on this stage. Now I want to check what's gonna happen if I melt my sample on stencil instead of using bed plate. I will also preheat the flat plate to avoid temperature shock. Looks promising. Sample slowly collapsed down. I can't see any small bubbles this time, so theory with air trapped between metal and plexi seems right. But there is something that concerns me. I think a big portion of air been already trapped inside. Okay, we'll figure it out soon. Yep, looks so. Anyways, let's just see the result. Well, except this big air pocket right in the middle, it looks pretty much okay. Let's give it one more shot, but this time in reversed order. I put a small drill on the bed plate to raise one corner of the sample, but unfortunately, samples slide down and stick immediately. So, okay, next time I guess. I will just make a small hole in stencil to allow the air to escape, and when all parts are hot enough, I can make another try. Okay, that already started looking like a lens. Unfortunately, even though I made this vent hole, I failed to release all the air, and I still need to remove this spot, which for sure will affect the surface quality. So overall, I think it's not the best way to deal with air pockets. I need to figure out something better, but for now, let's see what kind of post-processing I can do on it. Can I grind off those small bubbles on the flat surface? Oh, looks, yes. Of course, I also need to polish it as well, and... okay, looks transparent, but can I make it round? Let's check it out. I'll try to put it between two pieces of rubber and press it against the head of my lathe. Sure, the grip is pretty weak this way, but on the other hand, you don't need much force to turn plastic, so maybe it will be sufficient. And yes, it is. Easy, I can machine it without any problems. So now it's finally something I can call lens. Sure, it's still far from perfect, but works. I'm out of filament, so I need to wait till tomorrow for delivery, but not a problem. I have few things in mind that I can do in the meantime. First of all, I would like to try make forming process just a bit more predictable. So I'm building a holder for two stencils that should allow me to slide them against each other. Between I will put a disc of plexiglas and heat everything together up to 230 degrees. Hope this will also help in removing the air, as disc will be oriented vertically this time. Okay, this is ready. Tomorrow we'll see if it's worth something. Now I can play a little with my aluminium plate. After using few grades of sandpaper and some polishing, surface looks like this. Unfortunately, the highest grade of sandpaper I have is 1000, so it's not an ideal mirror, but at least it's way better than it was. I will just prepare two discs that will fit precisely to my tool, so they be ready for tomorrow, and I can call it a day. New roll of filament just arrived, so I can put my 3D printer back to work. Fortunately, I also managed to find the right settings for it this time. The print looks good, except some defect on top, which I will correct with sandpaper. I just make sure that I can't feel any irregularities on my dies, and I can proceed to make stencil. I will use the forming tool as guide. Let's use Vice this time to have the full set of pressing appliances involved in this project. And it looks good. Okay, I think I can see some small defect in the middle. Probably it would be wiser to use sandpaper while turning the die in the lathe, not just by hand. But okay, subject for further improvements. Let's just make second one. Cool, now I can finally assemble all parts together and give this concept a try. After around 10 minutes in 230 degrees, I just need to press it to the end and revert the package a bit to cut off the plastic left in the vent hole. Now as my thing cooled down, I can disassemble it and check the results. Which are quite disappointing, to be honest. Surfaces looks ugly, material is missing on the sides, but this time it's because it was simply too little plastic loaded to fill the space fully. Okay, let's just give it one more chance, but without this spacer ring this time. I will just make a bigger hole so I can see what happens if I tilt the disc a little. It's better, but as the disc wasn't exactly upright this time, there is some significant air pocket right in the middle. I can also see some strange damage to the surface right here. Not sure what was the reason that made it appear. Okay, this setup might be nice if I would like to try injection molding one day, but I think for now it's a bit over-engineered. Let's make a step back to more basic methods, just applying what I learned already. Actually, I didn't yet test if supporting one edge of the sample would prevent surface defects. Good moment for that. And it works! No small bubbles this time. The ones you can see are inside the plastic, and it's because I was too impatient to wait till samples are fully dry. So again they spent only 3 hours drying. But I will fix it next time. I also didn't try to make concave lens, so here we go. And you know what? Except insufficient drying, it's a pretty nice lens, like for how primitive methods I used to create it. I made it round on the lathe, and even though it has this defect caused by sloppy use of sandpaper, I'm already happy with the result. But am I able to repeat it with convex lens? Let's find out. I will try to apply pressure in such manner to, hopefully, push all the air out. I also melt my pen, but that wasn't part of the plan. And the result is ambiguous. I succeeded on making the air out, but on the sides I see some damage I think I've seen before. Missing plastic remains sticked to the stencil. Interesting. After watching the video in slow motion, I figured out that probably plastic just don't like to be pulled once it's already in contact with other surface. Just a theory, but corresponds pretty well to the observation. Good to know. But even with those defects, this is still a nice lens, like for my current technology level. Yesterday evening I've been googling a little about aspheric lens and found this article. This graphics demonstrates the difference between spheric and aspheric lens cross-section. I'm quite sure it's just conceptual drawing, not an actual geometry of some real-life optics, but I'm curious if I can make something that strange. I will also make spheric version for comparison and to try something of bigger curvature. I also seen some movies about polishing. One guy mentioned about using WD-40 as lubricant, and actually that makes sense. He also mentioned about using sandpaper up to 3000 grade, but well, still have only 1000. But I figured out that I have some polishing disc for Dremel, so let's introduce some power tools to the process. Nice. Still can be better, but results are visible. Meanwhile, my 3D printer finished the job, and this time it's nearly perfect. I just forgotten to randomize starting points, so I have this nasty line, which probably will cause some troubles later on, but let's see. My previous stencil had this shaper right in the middle, so this time I want to be more careful while finishing my dies. So I use lathe and fine sandpaper for it, first with high revolutions for the outer surface, then I slow down to make sure the middle is exactly round as well. I think it's good enough already. I also need to do the same for the bottom dies, and once that's done, I can start making stencils. I will just mark how deep it can go so that I know what I'm doing and I can assemble my tool. This time I thought that maybe it won't be stupid to have some lubrication while pressing, so I add some Vaseline and let's see what's gonna happen. I'm a bit intimidated by the depth of these dies. I hope the plate won't break this time. And it didn't. Stencil looks pretty decent. Image also seems to be fine. Okay, there is something here, probably caused by this line on the print, but it's on the side, so I don't mind for now. Don't know yet how it's gonna work for making lens, but I'm sure it would also be a nice reflector for LED, especially if I made it parabolic instead of spherical. Okay, let's make also the aspheric version. I'm even more concerned about the plate this time, but it works. Shape is weird, but it was supposed to be so. Means technology works as expected. Now I just need new bed plate to accommodate my new stencils, so let's make one. Here I pierced the plate intentionally, but that is exactly what I was worried about while pressing stencils. Every plate has its limits, beyond which it just breaks. Now just a bit of cutting and bending and I have my new bed plate ready. So let's make some experiments. I dried my sample 3 hours yesterday and additional 5 hours today, so should be dry already. Unfortunately, it's a bit cracked. Hope it won't spoil the result. This time I want to try melting it in sort of controlled manner. I noted that molten plexi doesn't stick to cold objects, so if I keep contact short, I will probably be able to guide it while heating up, so that most of it would end up where I want it to be, but without trapping the air beneath. Not the most convenient method, probably it would be better if I use hotter station instead of this improvised something, but as I don't have one, it is what it is. Besides, first I want to figure out if it even works. Okay, that looks like success. So I can put flat disk into the chamber so it can warm up a bit. And after a minute or two, I can stick it to one side of my mold and give it another few moments. Now I can press it to the very bottom and move the whole package out of chamber. I think this stage requires further improvements. Doubt I can do it without moving the plates against the mold. But let's see the result. There is some small defect on the flat surface, which I'm sure I could remove with sandpaper. And one crack turned into a line of bubbles. But this already works pretty well, like for my needs. Image is free of significant deviations, at least in the center. Okay, I think I can call it a success. Fine, let's see how it's gonna go with aspheric one. I have last piece of dry plexi, so I hope it will go smooth. So far so good. Let's press it. This time I want to avoid moving the parts, so I just put the entire package on the piece of pipe and give it some time to cool down. And, well, that is definitely not what I wanted to see. Yep, means that if I want predictable results of forming, I can't just rely on my hands. I need to build something that will constrain the moves and assure proper geometry. But curved side looks intact, so maybe I still can save this lens. Sounds like a challenge. So let's try. I used a drill to make this small pit in the middle. I'll try to mount it in my lathe. Hope it won't break. Okay, will it be enough to turn it? Yes, it is. Probably I'm pushing it up to its limits now, but fortunately it still holds. Cool, now I can sandpaper out the middle, and once I have bottom surface flat, I can make it round just like the other lens. And great success, which is very fortunate as I'm out of dry samples. As expected, shape itself doesn't make much sense, but it's quite close to what I intended to get. It's flattened a bit comparing to original, but I can always make proper correction for that, so as technology demonstrator, I think it done its job. Cool, so I managed to create several lenses. Neither of them is perfect, but after what I've seen, I'm convinced that it's achievable without employing some overly complex technology. Of course, if I like to improve the results further, I will eventually need to build something more sophisticated than I did. But I'm sure it still can be simple enough so I can do it reasonably easy. And I already have few ideas on that. First of all, I like to try injection molding. Itself it's an interesting subject and it can give me some manufacturing possibilities which are out of my reach for now. Of course, I don't mean to try recreating industrial solutions at home, as from experience, I know how deep rabbit hole such project can be. Besides, most of complexities of professional injection molding devices are for the purpose of fully automated mass production, which I certainly don't need. So I can simplify the process a lot to be more suitable for DIY applications. Means you can expect another video in near future. Consider subscribing if you don't want to miss it. If you have any questions, suggestions or just want to say hi, comment section is yours. Thanks for watching and see you on other videos.